Yeah, welcome to the video lecture series of computer programming using C language. In the last video, we learned about one-dimensional arrays. So in this lecture, we will be learning about two-dimensional arrays. So I already told you in the last class what actually an array is. I'll define once again. So by using this array, we have an option of storing more than one value with the same variable name. But if you are using that, we need to be ensuring like all the values should be of same data type. Like all the values should be of integer, all the values should be of float, or all the values should be of character or double. So all the values should be of same data type, and how many values you are giving, that much of memory will be allocated, and all will be allocated in the continuous memory location. So we can define an array as collection of homogeneous data type elements. And here you need to understand, like we already discussed in the last class, we have three types of arrays: one-dimensional array, two-dimensional array, and multi-dimensional arrays. And we will be learning about one and two-dimensional arrays only. And whenever you want to work with arrays, we need to follow the two-step process, that is declaration of an array and initialization of array. Same in case of two-dimensional also, we need to follow that two-step process. And here also, in two-dimensional arrays also, same like one-dimensional array, it is used to store more than one value. Okay. Whereas the difference between one-dimensional and two-dimensional is, with one-dimensional we can store only one row of value, but with two-dimensional we can store multiple rows of values. That means if you are saying multiple rows of values and each row is capable of storing more than one value, we will be getting an option of storing the value in the form of matrix or in the form of table. I'll show you here. If you want to store the data, that means if you are storing with one row, it is nothing but one-dimensional array, and in one row, let us consider you are storing 4 values. Now the same option, if you extend for multiple rows, that means you are storing 3 rows and each row is capable of storing 4 values each, then it is called as a two-dimensional array. So we will be getting an option of storing a table of values. This can be called as a table, or if you want to store values in the form of matrix also, then we can use this two-dimensional arrays. So I'll repeat once again, with two-dimensional arrays, we have an option of storing more than one value, and the values will be stored in more number of rows, and each row is capable of storing more than one value. So that can be referred as a table or a matrix. Right? So whenever you want to work with two-dimensional array, we need to follow the same approach, like two-step approach: declaration and then initialization. So let us first see how a two-dimensional array can be declared. So declaration always specify the array name and data type. So the syntax for two-dimension is, we need to specify the data type first, and then you need to give the array name, and we need to give 2 dimensions. First dimension talks about the row size, that means how many number of rows you want to specify in your table, and then you need to specify the column size, that means each row how many values you want to store, and it is common for all the rows. Suppose if you are saying 5 in the column, then each row is capable of storing 5 values. That means this row will be capable of storing 5 values, this row is capable of storing 5 values, and this row also capable of storing 5 values. So this value is fixed for all the rows, and this value talks about how many rows you want to store in the array. Right? And the dimensions are to be mentioned in the angle brackets like this. So as we are mentioning 2 dimensions, that's why it is called as a two-dimensional array. So you need to specify type. So if you specify type as int, then all values whatever you specify here should be of integer data type only. So if you take a simple example, I am taking int a of 3, 4, that is nothing but we want to store 3 rows. The same example here, 3 rows I am storing, and each row is capable of storing 4 values. So total of 12 values we can accommodate in this table. So all these values, 12 values, can be accepted by using an array name called A, and all these 12 values are of integer data type only. So this is how a two-dimensional array can be initialized. A two-dimensional array can be declared. Now once it is declared, how the memory allocation will be done, I'll show you. So let us consider you have declared an array like this. A is an array name, and we are storing 3 rows with 4 values in each row. Then first row will be created with 4, and then second row, and then third row, and then 4. Right? 3 rows will be created, and each of 4 values. Now how the indexing will be done? Each row, so this indexing talks about the row indexing. Okay, this row talks about the indexing. So always indexing starts from 0. So we have row index of 0, 1, 2. Okay, and then this talks about the column indexing. This one talks about the column indexing. So we have 4 columns and the indexing starts from 0 to 3. Got it, all of you? So if you want to access an individual element, then that can be accessed by using the array name and mention the row index and then the column index. Right? So this talks about the particular row index and this talks about the particular column index. Suppose if you want to accept this first value, then the first value will be accessed as A of row index. What is our row index? The row index is 0 and the column index is also 0. Okay, and suppose if you want to accept your second element, this will be your second element, then the row index is 0, right, and the column index is 1, so you will be accessing like this. So always you need to specify the row index and then you need to specify the particular column index to access the particular element. So third index will be, this element index will be your row 0 and your column 2. So it is 0, 2. The name will be common. A will be the common name for all these elements. Similarly, if you see your 12th element, the 12th element row value will be 2 and the column value will be 3. Right? So this is how individual elements can be accessed. Memory will be allocated like this. But here you need to remember one thing. The values for your in the memory for your two-dimensional arrays will be stored row by row. That means first all these values. Remember, in memory for arrays, the data will be stored in continuous memory memory only. So if it is one-dimensional array, there is no confusion. First this one, next this one, next this two. But if it is two-dimensional array, how it will be stored? The data will be stored row by row. You need to understand, row by row the data will be stored. That means first in the first memory location, first this data will be stored, and then in the second memory location, this data will be stored, and in the third memory location, this data will be stored, this one, and fourth memory location, this data will be stored, and coming to the fifth memory location, this data will be stored. So once this everything is stored, then only it will go to the next row. So row by row the data will be stored in your memory. That you need to understand, all of you. So in two-dimensional array, memory will be allocated and values can be accessed row by row only, not like this, not like this. It will be accepted row by row only. Okay, so let us see the initialization. Initialization is nothing but we want to assign the values into a two-dimensional array, and that can be done at compile time and at runtime. Compile time is nothing but in the program itself you want to initialize, and that can be done in two ways. The first way is assigning the individual array elements, same like your one-dimensional array how you have done, by using the indexing, like array name you need to mention and then give the row index and column index and give the specific value for that. Let us consider this is the array you have declared like this. Then how many values we can store? 12 values you can store. To give the values you need to write 12 statements. As an example I have shown here, the first value, if you want to store a of 0, 0, we can store 10, and a of 0, 1 represents the second value. So individual elements can be stored by using this indexing, row index and column index you mentioned, and use the assignment operator and give the values. So what is the problem with this one is, suppose if you give 10 by 10, then that means we need to write 100 values, then we need to write 100 lines of statements like this, which is very big task. To solve that one, we can have a second option of combining the declaration and initialization, which can be done like this. We need to specify the data type, array name, you need to specify the row size and column size, and then we need to mention the list of values. Observe here, row size and column size is must, whereas in one-dimensional array no need to specify the size at the time of declaration and initialization. Okay, to do this task, let me show you this example, the same example for this one. Int a of 3 to, if you say all the values, 6 values I have mentioned here, that means we will be having 3 rows. Let me show here, we will be having 3 rows, 1, 2, 3 like this, and each row is capable of storing 2 values. So first 2 values will be 10 and 20, and the next two values will be 54 and 66, and the next two values will be 12 and 77. Like that, the values will be initialized. So we have another alternative also. If you are not mentioning like this, then we can mention each row separately by putting row by row in a flower brace like this. So this mentions the first row, this mentions the second row, and this mentions the third row. Like this, row by row also we can show the differentiation by putting that one in the separate flower braces. Okay, so suppose if you see in this example, this is first row, two elements are there, okay, but in the second row only we have given one value. Then what happens? It will take the second value by default, it will be stored as 0. That means if you see 10 and 20 will be stored, and the second row will be, first value will be 54 and the second value will be taken as 0 by default. Got it all of you? So that is way this is also can be done, or else I'll show you the representation. So I have cleared everything. Now if you see individual elements, how it will be stored. So it will be storing in the index A of 0 0, 10 will be stored. That means how it will be stored. A of 0 0 memory location will be holding a value of 10. Then A of 0 1 will be holding a value of 20. A of 0 1, remember row by row, we are telling 3 rows, 2 columns. That means each row will be having 2 values. So second row will be having a value. That means first row, second value will be the second value. Okay, and then we are saying A of 1 0. Observe here, we are talking about this one. This is our example. Let us consider. Okay, let me highlight that. So let us consider this is the example we are talking. So first value will be 10, 20 is already stored. Next value is now 54. That will be indexed with A of 1 0. Okay. Next value is A of 1 1, that is 16. That will be stored in your fourth memory location. And then remaining two values will be stored like this. So this is how memory will be allocated. Row by row memory will be allocated. That you need to understand. So in arrays, two-dimensional arrays, the values will be stored row by row. Okay, this is how compile time initialization can be done. Okay, and it is also possible if you are specifying individual row like this, like separately row by row, if you are grouping, then if you don't mention the row size also, that it is okay, but you need to specify the column size. If you don't mention this column size, that you will be getting an error. If you don't mention the row size also, it is okay, because we are grouping them into rows. And if you want to initialize all the values in the 3 by 2 matrix, then you can simply write like this, because the other values will be obviously taken as 0. Okay, so these are the different ways how can we initialize the values at compile time. Okay, now let us see how to initialize the values at runtime. Runtime is nothing but we want to use a scanf statement. So normally we are mentioning two for loops here. First for loop is to mention the row size, and second for loop is to mention the column size. So let me show you that one. I will take this initially. Let us talk this one, I value. We are mentioning 3 rows and 2 columns. So 0, 1, 2, and then 2 values. That means each row will be having 2 values. So this is 0 and this is 1. Now initially I value will be talking about rows. I told you I value will be talking about rows. So initially I value is 0 and it will enter into this loop. Now j value is 0. So j, this one is j value is 0. And then it will enter into the loop. Whatever value you give, that will be stored in A of 0 0. What is A of 0? A of I say A of 0 0. So whatever value you give, that will be stored here. Next, what happens after this loop, the control will come here and the j value will be incremented. Now your j will be this one. Now it will asking you the second value. That value will be stored in A of 0 1. That means whatever value you give, that will be stored here. Now again the loop will be incremented. J value will be now 2. 2 is less than 2, which is false. So it will come out of here, and now no statement is here. Then again it will go back to here. Now the I value will be incremented. Now I value will be this one. Okay. Now this is how the same loop will be repeated. You will be getting the next 2 values and the next 2 values. Got it all of you? So to print the values, same thing, you need to use 2 for loops and you need to print that one. So one loop is for row and the other loop is for the particular 2 number of values for that. That means representing the column values. Okay, the applications of two-dimensional arrays is matrices. We will be learning in future how to perform all these matrix operations and all. Okay, so with this we'll come to an end of our today's lecture, where we learned about in detail about two-dimensional arrays. Okay, let us all meet in our next lecture. Until then, thank you all of you.